Hello guys, today we are going to talk about some examples of integration by part. Okay, so here is one of the examples. Okay, and this is not a common example you will do in like homework problem, but you will get it in an exam. Okay, so let's start it. Okay, so in this kind of problem, it's actually pretty easy. You just have to know that this is integration by part. You have to use integration by part, and you need to know the value they're given, what it represents, and what it can be used for. Okay, so let's do it. Okay, so in this case, we given the questions is f prime x dx, and we can know this is an integration by part because we have an algebraic function and we have another function that is unknown, can be anything, can be e to the x, can be sine x, can be cos x, can be trigonometric, can be inverse trig, can be anything. So in this case we can just use integration by part. So in remember the formula LIATE. So we let u equal to x, right? Because a is the algebraic. However, in this case, we don't know what is the f prime x, f double prime x. So we can just, however, we can integrate it because this is the second derivative of f of x. Okay, so u is equal to x and du is just equal to dx, and v prime will equal to f prime x, f double prime, and v will equal to f prime x. So if you integrate a second order of derivative, you will get back the first order. Okay, and now you can just apply the formula. However, this is definite integral, so you have to note that you have to sub in the 4 and 1. Okay, so you get uv, which is f prime x, and I recommend you to write you solve it differently. You don't combine all the 4 and 1 in one equations. Okay, so you can just write in minus integral of v du, which is f prime x dx, and remember here it has 4 and 1. Okay, we haven't solved this one. Okay, and let's continue, and this is just a simple integral. Okay, you just if you integrate a derivative, you will get back the original functions. Okay, so we just write down you get fx and for 1, and of course now you can just do by substitute the value. You will get 4 times f prime of 4. So I will write a bracket here and you get f prime of 1 because 1 is just 1 minus f of 4 bracket minus f of 1. And remember the value is given. Remember, yeah. So you got f1 equal to 1, f4 equal to 8, f prime 1 equal to 3, f prime 4 equal to 5. And you can just substitute it. So f prime 4 is what? Is 5. So you will get 4 times 5 minus f prime 1 is 1. Oh, sorry, it's 3. It's 3. And you minus it with f4 and minus f1, right? So it's 8 minus 1. You just get 8 minus 1. And you eventually get 17 minus what? 7. And your final answer will be 10. Okay? So this is a odd example that you won't usually see it in a homework problem. Okay? Okay, let's go on to the second example. Okay. The second example will be just you require more efforts to do this problem. Okay, so it will be e to the x, e to the x sine x dx. Okay, this is some common example you will see in exam. So usually you have to integrate twice. Okay, we will see when we solve the problem. So in this case, it's integration by part because we have an exponential and we have a trigonometric. Okay, so u will just equal to, remember the LIATE, so u will be equal to log trigonometry, and e equal to x is exponential. Okay, so u equals sine x, and du is equal to cos x dx, and v prime is equal to e to the x, and v is equal to e to the x. It's the same thing. Okay, then we can just sub in the formula uv sine x uv minus the integral of v du, which is cos x e to the x dx. And now, did you notice that you can't straight away integrate this one? Like, you can't directly integrate. You have to use some technique for this case because you left out a trigonometry and exponential again. So how do we do it? And since this is an integral, so we can do it again. We can integrate by part again. Okay, so u will equal to cos x, the same, and du equal, remember it's negative sine x. Okay, dx, and v prime is equal to e to the x, and v is still e to the x. Okay, so we can do the integration by part again. So we will get e to the x sine x minus uv. Remember bracket, sometimes you will mess up with the sign. Okay, u is cos x, v is e to the x minus integral v du, which is, since du is negative, so it will become a positive. Okay, which is e to the x sine x. Oh, okay, sorry, e to the x sine x. Okay, and dx, remember. And now we get this one, and we see another one in another integral, which we cannot solve it directly, right? We have to use integration by part. So maybe we can use it again. However, if you notice, this thing is actually equal to the questions given. It's exactly same, right? So what can we do is, since we know that, okay, e to the x sine x dx is equal to this whole expressions, right? E to the x sine x minus, we expand the sign, so we get, okay, I will prefer to put e to the x in front because it's nicer. E to the x cos x minus integral of e to the x sine x dx. This is the whole expression, right? If we move this integral to the another side, so we move this to here, which add, right? Because from negative we move to the other side is plus. We will get what? We will get a 2 e to the x sine x dx, and we equal e to the x sine x minus e to the x cos x. And remember, this is the question we need to find. So we can just divide 2 from both sides, and we will get the answers for the integral of e to the x times sine x dx, right? So we just divide by 2. We will get e to the x sine x minus e to the x cos x over 2. And remember, plus c, because this is an indefinite integral. Okay, and yeah, this is our solutions. This is what the question wants, right? And we give the answers. Okay, so this is one of the example of doing multiple integration by part. However, in the future, you might have to do 3 times, 4 times, or 5 times to get the same, the same pattern. You will realize. Okay, and yeah, thanks for watching the videos. This is about it. Hello guys, thanks for watching, and this is my second videos of integration by part, and we will move on to trigonometry substitutions in the next videos. And thanks for watching, and subscribe and like and share.